सब्सक्राइब कीजिए ईएसए क्लासेस चैनल को और बेल आइकन दबाइए हमारे लेटेस्ट वीडियो सबसे पहले देखने के लिए।
The wave nature of matter. In 1924, de Broglie said, de Broglie, the pronunciation is de Broglie. The de Broglie said, if light has wave as well as particle nature, then particle also has wave nature. Light has wave as well as particle nature, then particle also has wave nature. Lambda is equal to h upon p. He said wavelength of particle is equal to h upon p. H is the Planck constant and p is the momentum. This has no theoretical proof. Validity of this can only be tested by experiments. And this is also applicable to photons. Lambda of microscopic objects cannot be detected. If I throw this pen, then this pen also has wavelength, but this cannot be detected because it is very small. In 1929, de Broglie got Nobel for this. This matter wave picture incorporated uncertainty principle. This also supports matter wave picture supports uncertainty principle. Properties of matter waves. Intensity of matter wave gives probability of finding a wave in this space. Gives probability of finding a particle in the space. It is not electromagnetic in nature. It is independent of charge. Matter waves can be observed only if lambda is approximately same as size of the particle. Electron microscope works on the same principle. Phase velocity of matter waves can be greater than velocity of light, and they can propagate in the vacuum. This matter wave picture supported second postulate of Bohr. As per the theory of stationary waves, only those waves survive on the string which complete integral multiple of lambdas for a entire path. So entire path for electron, this is nucleus. For entire path of electron, entire path of electron means circumference, that is 2 pi r. So 2 pi r is equal to n into lambda. Lambda is wavelength of electron. So I can put lambda as n into h upon mv. If I shift mv at left hand side, and r and 2 pi at right hand side, then this becomes mvr is equal to nh upon 2 pi. So this is exactly the Bohr's equation. So we can calculate Bohr's equation. We can find out Bohr's postulate from de Broglie hypothesis. Then if an electron is accelerated through potential difference V, then wavelength of that electron is 12.27 upon root of V. V is potential difference between which electron is accelerated, angstrom, or it is h upon p, and momentum is root of 2m e into v. Then final Davison and Germer experiment. It was performed in 1927 and 1928 respectively by Davison and Germer. It proved wave nature of electron. So this is the arrangement of the experiment. This is the arrangement of the experiment. Here arrangement is like this. So this is the electron gun. From electron gun, electrons are emitted. Fast moving electrons are bombarded on the nickel crystal. They get diffracted. Diffracted electrons are detected at this place by detector. Detector is connected with galvanometer. Current more in the galvanometer means electron more striking the detector. This entire chamber is evacuated. This is tungsten metal coated with barium oxide. This is low tension battery. This is high tension battery. High tension accelerates electron, and low tension emits electrons. So electron which are detected by detector, their lambda is calculated by using de Broglie principle, and their lambda is calculated by using diffraction principle, and both lambdas are same. Therefore we can say that electron has wave nature. And constructive interference happens for phi is equal to scattering angle is equal to 50 degree, and potential difference HT should be 54 volts. Okay. A relation between scattering angle and glancing angle. Glancing angle is 90 minus scattering angle by 2. Diffraction formula is this: lambda is equal to 2d sin theta, d is 0.91 angstrom, theta is glancing angle this much. This formula gives the lambda by diffraction formula, and this formula gives lambda by de Broglie formula. This is the lambda from de Broglie, this is the lambda from diffraction formula, and both lambdas are approximately same, 1.65 from this, 1.67 from this. Both are equal, therefore electron has wave nature. Two more points about atomic emission. Emission line spectra of a material can act as fingerprint of that material. Emission line spectra of a material can act as fingerprint of that material, and Bohr's model correctly predicts the frequencies emitted by hydrogenic atoms, but cannot explain relative intensities of the frequencies. Then mass defect. Mass defect is difference between expected mass minus actual mass. Mass defect is difference between expected mass minus actual mass. It is Zmp plus A minus Zmn minus actual mass. Mp and Mn are proton and neutron masses. Difference in mass is converted into energy as per Einstein's equation. E is equal to delta m into c square. That energy is called binding energy. And it is used to bind all the nucleons. Binding energy per nucleon indicates stability of nucleus. If it is more, then stability is more. If it is less, then stability is less. This is the graph indicating binding energy per nucleon on y-axis, and on x-axis A. If A is between 30 to 170, then binding energy is almost constant. For ferrous 56, binding energy per nucleon is maximum, it is 8.75. It is low for lighter nuclei as well as heavy nuclei. Heavy nuclei break to form lighter nuclei, and it is called fission. It is called fission. Lighter nuclei combine to form heavy nucleus, and that is called fusion. Fission and fusion happen to increase stability. Then radioactivity. Phenomenon of spontaneous emission of radiations from a radioactive substance is known as radioactivity. It is unaffected by chemical and physical changes. Important. Chemical physical changes does not affect radioactivity. Radioactivity is property of nucleus. As long as nucleus is unchanged, radioactivity remains same. So, radioactive elements decay, emit alpha particle, beta particle or gamma ray. Alpha particle is nucleus of helium, beta particle is either electron or positron, and gamma particle means electromagnetic wave. Charge on helium is 3.2 into 10 raised to minus 19 coulomb and its mass is 4 AMU. Mass of electron or positron is 9.11 10 raised to minus 31 kg and charge is 1e 1.6 10 raised to minus 19 on positron plus on electron minus. Electromagnetic wave has no charge, no mass. Alpha particles get deflected, beta particles get deflected. EMWs, gamma rays do not get deflected by electric field and magnetic field. Velocity 1 by 10 to 1 by 100 of velocity of light, c by 10 to c by 100. Velocity is c by 10 to c, but not c. Here velocity is c. Shows fluorescence, does not show fluorescence. Ionizing power is maximum. Ionizing power is 100th of alpha particle and ionizing power is 1000th of alpha particle. Penetration power maximum, penetration power minimum. Only penetrate 2.7 to 8.62 centimeter in air. Can penetrate 1 meter in air. Can penetrate 25 centimeter in iron. 25 centimeter in iron. Then when alpha particle is emitted, A decreases by 4 and Z decreases by 2. When positron is emitted, A remains same, Z decreases by 1. When beta is emitted, negative beta electron, A remains same, Z increases by 1. When electron is emitted, neutron is converted into proton, and when positron is emitted, proton is converted into neutron. This is antineutrino. Antineutrino is emitted with electron and neutrino is emitted with positron. Then radioactive decay law. dN by dt minus dN by dt is proportional to n. N is number of molecules available at that time. Then minus dN by dt is equal to lambda, and lambda is proportionality constant called decay constant. Then relation between n and n naught. There are two relations. N is equal to n naught e raised to minus lambda t, and n upon n naught is equal to half raised to n. Small n is number of half-lives. N is remaining number of atoms, and naught is initial number of atoms. Tau is mean time. Tau is mean life or time constant. it is 1 upon lambda. Within tau time 63% disintegration happens. Within tau time 63% disintegration happens. Disintegration happens 63% means 37% atoms remain. 37% atoms remain. Then half-life T half is 0.693 upon lambda. Then 1 Curie is 3.7 into 10 raised to 10 disintegrations per second or becquerel. 1 becquerel is the SI unit and it is 1 disintegration per second. 1 becquerel is SI unit and it is 1 disintegration per second. 1 Rutherford is 10 raised to 6 disintegrations per second. Then Chadwick discovered neutron in 1932 and he got Nobel in 1935. Then nuclear force, it is stronger than gravitational and Coulomb force. If distance between two nucleons is greater than few femtometers, if it is 10 femtometer, 5 femtometer, then force between nucleons becomes 0. If distance is less than 0.8 femtometer, femto means 10 raised to minus 15. If distance is less than 0.8, force is repulsive. If distance is greater than 0.8, then force is attractive. It is independent of electric charge. That means proton-proton, nuclear force between proton and proton, nuclear force between proton and neutron nuclear force between neutron on neutron, neutron and neutron, all are same. Then, no simple mathematical formula is available for nuclear force. For Coulomb force and gravitational force, formula are available. For Coulomb, Q1 Q2 upon R square. For gravitational force, G M1 M2 upon R square. Then, neutrinos are neutral, very small mass compared to electrons, or almost zero mass. They can penetrate large quantity of matter without any interaction. Gamma decay happens when nucleus comes from higher energy state to lower energy state. Fission. If uranium is bombarded with neutron, this fission happens. This type of fission happen, or this type of, or this type of. Anything is possible. But after fission, smaller nuclei are generated and smaller nuclei are more stable compared to uranium. And 3 neutrons are also emitted, here 4 neutrons are emitted, here 2 neutrons are emitted, and these neutrons are responsible for further fission reactions. Now these fragments which are produced, they are not stable. They emit beta particles. Then inside nuclear reactor, all 3 reactions happen. Inside reactor, all 3 reactions happens. In each reaction, a different number of neutrons are produced. So average 2.5 neutrons are released per fission. Slow neutrons are useful for fission and fast neutrons are not useful for fission. Fast neutrons escape out of the reactor without causing fission. Fast neutrons are not useful, slow neutrons are useful. Slow neutrons are also called thermal neutrons. Average energy of neutron generated is 2 mega electron volt. These are very fast neutrons. Neutrons generated in the reaction are fast neutrons. They are not useful. We need slow neutrons for fusion. So to decrease speed of the neutron, moderators are used. Those are water, D2O, heavy water, or graphite. K is multiplication factor. It is fissions produced upon previous fissions. Fissions right now upon previous fissions. If multiplication factor is 1, then rate of reaction remains same. then this is called critical operation. If K is greater than 1, then operation is called supercritical and rate of reaction increases and it may lead to explosion. If K is less than 1, then rate of reaction decreases continuously. So if K increases beyond 1, then control rods are used to absorb neutrons and decrease the speed of reaction. For example, cadmium. And there are safety rods as well. Safety rods decreases K drastically and make reactor safe. So this is the reactor. These are the reflectors. Reflectors are used to avoid leakage of neutrons. Control rods to control speed of the reaction. This is safety rod. If reaction goes beyond control, then safety rod is used. Moderator is inside the core. Moderator is used to decrease the speed of the neutron to make slow neutrons from fast neutrons. And this is coolant. Coolant extracts heat from the reactor and gives it to the water. Water becomes steam and steam is used for electricity generation. Then nuclear fusion. Hydrogen plus hydrogen becomes deuterium by liberating some energy. Deuteron plus deuteron becomes helium. Deuteron plus deuterium becomes tritium, triton, nucleus of tritium. So these three types of reaction are fusion reactions. For fusion reaction, nucleus of hydrogen and nucleus of hydrogen should come very close to each other. For them to come very close to each other, they need 400 kilo-electron volt energy, and temperature required for that is 3 into 10 raised to 9. Core of the sun is at 1.5 into 10 raised to 7 Kelvin. That temperature is much less than the required. So protons in the sun have much higher energies than the average energy. Reaction in the sun. This is the reaction in the sun. When 4 hydrogens combined, 1 helium is generated, 2 electrons, 2 neutrinos, 2 gamma rays, and 26.7 mega electron volt energy is liberated. After sun has a lot of hydrogen. If hydrogen is depleted because of this reaction, then helium can be used as fuel. Age of the sun is 5 billion years and it will be there for 5 more billion years. If we can control fusion, then it could be a very good source of energy on the earth. But controlled fusion is very difficult because at 10 raised to 8 Kelvin, controlled fusion needs around 10 raised to 8 Kelvin temperature. At this temperature, everything converts into plasma. Plasma means positive ions and electrons. Means at this temperature, hydrogen atoms are not present. Nucleus of hydrogen and electrons of hydrogen, they become separate. So plasma means combination of positive ions and electrons, and no material can withstand this much temperature. Therefore controlled fusion is very difficult.